Okay, welcome to the next tutorial. In the previous tutorial we've covered getting our red window to work, figuring out how to get our program to see that our system has GLFW and GLEW, which is Graphic Library Extension Wrangler, Graphics Library Framework, and stuff like that. Okay, well in this tutorial we're going to cover installing the compiler, and we're going to make our first point, our first vertex, or our first vertice, which programmers and 3D modelers know or understand as vertices, vertexes, and stuff like that. So that's what we're going to cover in this video right here. First things first, what I want you guys to do is go to this website right here. This website where you can download TDM GCC, because that's the compiler I'm using, and you want to download the 32-bit, which is at the bottom right here, 10.3.0, I'm sorry. And you want to download that, and we're going to go ahead and get this installed. No, we're going to get it installed. I have it right here, I already downloaded it. And we're going to create these. You can see right here I already do have it installed, but I'm going to show you guys what you need to do to get it installed on your code box. Okay, we will create, we'll go ahead and uncheck, make sure this is unchecked, and we will create, and we're going to go ahead and find our code blocks folder where we installed our code blocks. Okay, and that's located in the C drive. Open the window, and we're going to, this is where our code blocks is. Okay, so what we want to do, we want to create a new location where we can install our compiler. Okay, so we'll go new, continue, and we'll call it TDM GCC for this new folder that we created. Okay, and inside here we're going to create an X32 folder, which means 32-bit. X32. Okay, and we want to take this path right here, copy, we want to install it. Actually, it's best we do a browse here. Browse. And you want to locate your 32-bit folder, and you want to click OK. And you want to click Next, and click Install, and it's still everything that installs from here should start showing up in this folder right here. So we'll click Install. There we go. And there you have it. We have our compiler installed now. Okay, we'll click Next. Uncheck that. We don't want to read anything. We want to click Finish. Okay, so now we have our 32-bit installed. Again, this is where our compiler is in our code blocks, TDM-GCC. Okay, so we'll go ahead and close that out. And so what we're going to be doing, we're going to be covering page 13 and 14, and we're going to get this little black window up, and in this little black window you're going to see your first vertex is going to be colored blue, and you have to type everything correctly to a T in order to get this thing to work, because you type one thing wrong and it won't work. You'll get a white dot, you get a red dot, but you want your dot to be blue. So we'll go ahead and make sure you go ahead and download the 64-bit version also of TDM-GCC, because you might wind up needing it for in the future. But for this specific tutorial, you just want to do 32-bit, but download both of them, 64-bit and 32, for ease of mind. Okay, so let's go ahead and open up this red window right here, the red window. Let's set up our compiler. I mean, it was already working in the previous window, but I want to show you guys something. How to switch compilers. You already know how to switch compilers, but I'm showing you how you can set up so that it can work with TDM GCC. Okay, so go ahead and double click that. And you want to go up to Settings, As you can see, it's already working. I mean, you do get the red window, but if you don't have a working compiler, you want to switch to that compiler that you installed. Code blocks. Let's take, for example, we'll grab another compiler like a VC10, Microsoft Visual Studio compiler, and it won't work. And you can see it's not working. You try to rebuild it, you try to play it, it's not working. Okay, so we'll go ahead and grab our GCC compiler. Code blocks, GCC, we'll select the folder, click OK, and it should work. It's still not working. Setting, compiler, go back into it. And we'll put it back to GNU GCC compiler, set as default. And we'll take it off the Microsoft Visual Studio. And we'll go to TDM GCC, select folder, click OK. I will hit F9. We're going to rebuild. No, it's not working. Compiler, GNU GCC. Oh, that's why. Because we didn't go into X32-bit. Okay, so now go code blocks, TDM GCC. Click on the X32 folder. Select folder. Click OK. And it should work now. Do you want to build it now? Yes. There we go. So now it's working. Do another run to rebuild. And it works. Okay, so that's how you go about setting up your compiler. And alright, so what we're going to do from here is we're going to cover. We're going to get our hands dirty and we're going to start programming our way into our first Vertex. Okay. Now I'm going to set this up. Let me get this out of the way. GLF window. Alright, so we're going to go ahead and move all this stuff down. And we're going to take this stuff out the way, because we're just going to type this over again. So we're going to put all that stuff at the bottom right down there. And we're going to start entering syntax so that we can have our first vertex point right here. Okay. Alright, so what you're using namespace std do? You're using namespace std is a collection of related names or identifiers, functions, class, variables which help separate these identifiers from similar identifiers in other namespaces, or the global namespace, in other words. Okay, so that's what your line here is doing. Okay, we're going to type define num vaos. We're going to put 1. Okay, and what this line does is it's an object that describes how the vertex attributes are stored in the vertex buffer object, or VBO, in other words, for short. Okay, that's what a VBO is. You're going to see VBO in these tutorials later on. That's what a VBO is. VBO is a vertex buffer object. But okay, in this line right here, we're defining an amount of 1 vertex array object. That's pretty much what we're doing. Okay, so I'm going to go ahead and that's the description right there. Okay. Okay, this is the next line right time. Okay, and this is GLUint rendering programming. Okay, now this is pretty much used to abstract the creating of objects and buffers in the GPU, or graphical processing unit, and it acts like a pointer to them in the graphical processing unit memory. GLUint is just a type for a number, so it's pretty much an unsigned binary integer of 32 bits. Okay. Okay, it's GLUint again, vertex array object, number of VAOs. Okay, we're going to get our little shader program up now. Okay, we're going to work with a vertex shader and fragment shader and everything. So we'll go ahead and type in GLUint create shader program. Create shader program. Okay, and this is a vert and frag shader that are little shader programs inside of our application. Okay, so that's what we're working with now in this section right here. Okay, now we're going to type const character star vertex shader source. Okay, v shader source equal to, and then we're going to type in this little. We're going to type up this little shader program of ours. Okay, now in GL position, which is equal to vec4. Okay, these numbers right here are a representation of the location of the vertex. It's a representation of x, y, and z axis. Okay, 0.0 is the x, this is y, this is z axis. And I don't know what this one is, I totally forgot, but maybe somebody else can explain that to you. Okay, and we got another const character, but this one is not the same as the one up here at the top. This one is for f shader source. Okay, so this is const char f shader source, not v shader source. Okay, this is version 4.430. Make sure you type all that stuff correctly. Okay, and don't forget the GL position is a capital P. This is a capital P right here, so make sure it's capitalized and not lowercase. That's one mistake I made last time when I first started typing this up. Okay, this is out vec4 color. Okay, so now we got a void main. And we're going to set up the color is equal to vec4, and these numbers right here are a representation of the color of the vertex, and it's red, green, and blue, and alpha. Okay, so this is red, this is green, and this is blue. Okay, so this right here, since you have that 1 there, the vertex point is going to be blue, and this is alpha. Okay, so it's 1.0 for alpha. That's what the book tells us to put, so I'm going to put it. Okay. So type in GLUint v shader. GLUint v shader is equal to GL create shader GL Vertex shader. Okay, so that's for a Vertex shader. This is for a fragment shader, which is the same line, but it's representing the fragment shader, not the Vertex shader. Okay, so this is GLUNF shader, GL Create shader, GL Fragment shader. This is GLUNVF program. Okay, so that's the program that we're writing. We're writing a Vertex fragment program, which is equal to GL Create program. So we're creating this one, or we're writing this one, and that's what that line is pretty much helping us. It's identifying what we're writing, what we're typing up. Okay. Okay, so GL shader source. Okay, replaces the source code in the shader object. Okay, GL shader source V shader 1 and V shader vertex shader source null. Null means 0. Okay, so this is V shader source. Make sure it's lowercase s, capital S for source. GL shader source. Okay, and this is the exact same text but for fragment shader. Okay, so GL shader source F shader 1 and F shader source is equal to null. GL compile shader V shader, GL compile shader vertex shader. That's what that's for, and we got the same line here. We could change it to an F. GL compile shader F shader. Okay. Okay, and this attaches this GL attach shader VF program, comma V shader. Okay, this is something for the for both programs, the Vertex program and the F and the fragment program. Okay, this pretty much attaches the shader object specified by shader to the program object specified by the program. Okay, this indicates that the shader will be included in the link operations that will be performed on the program. Okay, so we're going to enter this line right here. I'm not typing all this stuff up again, because then if I do, I have to look for errors and mistakes, and I didn't put a comma here, I didn't put a semicolon there, so I'm just copying and pasting. Everything you see here needs to be typed the exact same way, or else you're not going to get the same results that you're looking for, the same results that I get. Okay, so this is GL attach shader VF program fragment shader. Okay, notice how these lines look the same, but they're not the same. Okay, this is a V here, there's an F down here. Okay, that's one thing you don't want to make a mistake with. You don't want to put the same thing twice, because you know two lines look the same, they're not the same. One line has F, one line has V. Okay, graphics library link program VF program. Okay, this links a program object. Okay, and we're going to return VF program. Okay, this will terminate the function and return the value to the caller. Okay. Yeah, so now we're going to go down here. We're going to go past this curly bracket right here. We're going to start with a void. void init. Okay, and this is rendering program is equal to create shader program. Okay, this creates a program object containing compiled, does I say compiled and linked shaders for a single stage specified by type. Strings refers to an array of count strings for which to create the shader executables. Alright, so this is GLGen Vertex arrays, number of VAOs, VAO. Okay, again, we know what VAO stands for, vertex array objects. And this generates a name for the vertex array object. Okay, this GL bind vertex array VAO 0. This binds the vertex array object with the name array. I'm going to bring that up here. Okay, this is void display. GLFW window star window double current time. Okay, I don't know what that line does. And this GL use program rendering program. Okay. Okay, this installs a program object. It's pretty much right here. It explains what this line does right here. All that stuff. Okay, GL draw arrays. GL points 0 and 1. Okay, this draws your point and vertices. This line right here is going to draw that point right in the middle of the screen. Okay, so that's pretty much everything. Let's give it a run. Okay, so it looks like a black window, but if you look close enough, you see that there is a little black dot right there. No, not a black dot, a blue dot. It's a blue vertex. It's right there in the middle of that square right there. And you can't see it. Okay, so we want to make that larger. In order for us to make that point larger, you go down to GL draw arrays. Change and we need to put GL point size. Oh, it's right there. .0 float. Now we'll run it again, and the point is going to be a lot larger. You can see it's a lot larger, so now you can see that. That's 1 point. That's a vertex point. But it's at a size of 30.0. Size of 30. Let's see what it looks like with a size of 60. Boom, you got a big old fat vertex right there. Let's give it a size of 100. It's pretty cool, huh? Let's give it a size of 200. See? So it looks like just a little simple square, but it's actually a vertex. It's actually a vertex. You can play around with it a little bit. And if you don't want it to even be that big, if you don't want it that big, you can just cancel it out. You hit F9 and launch it, and you still won't be able to see it again. Alright, so that's our tutorial for the Vertex. You just made your first Vertex. Congratulations. But you got a long way to go. And so do I when it comes to 3D graphics, programming vertices, triangles, faces. And we're going to get into a lot more other things. We're going to, get into programming cubes, programming our own little OBJ loader and everything like that. And we're going to be programming graphics. Everything you look through in this book, everything you see in this book, we're going to be programming it up, typing it up, and I'm going to provide you with the files from this book. Now, all I ask that you guys do is just go ahead and purchase the book so you can actually have it for your own. I'll just do little reviews on this book and everything. But go ahead and purchase it off Amazon. It's a real good book. The paperback or get hardback, whichever one you want. It comes with the companion CD, and in the companion CD it comes with all the files that you're going to need in order to follow along in these tutorials right here. I'll provide you with the files because I already have the companion CD. I'll provide you with the files that you need in order to follow along if you don't have the book. But go ahead and show those professors and show them a little support and purchase the book from them. And that's pretty much it. Thanks for watching the video.